Hello and welcome to lesson 3.1 linear relations. Today we're going to start looking at relations that are listed as patterns that can be described in various different ways. One way is a table of values, another way is a graph, and another way is an equation. So we're going to explore what such relations are and show how to describe them using these various different forms that we've talked about right here. So let's jump right into it. So let's say in our first example, we first observe a plant, and at the first time during the one day, we notice that it's 3 millimeters tall. It grows to be 1 millimeter taller each day, or longer each day, and what we can do is we can describe this information in a table, sometimes also called a table of values. So with the table of values, what you do is you start with your independent variable, which in this case is just time, specifically in days. The dependent variable depends on how many days I have actually passed, which will give us the height of the plant, which is in this case, millimeters. So you start it with that information, and then you start it with the information that you have, what's being displayed as time goes on, and what the height is. So let's say the time starts at 0. My apologies. Time starts at 1. On the first day, you already know it's 3 millimeters tall. On the second day, you notice that it's 4 millimeters tall. On the third day, you know that it's 5 millimeters tall, and so forth and so on. So you don't have to keep listing every single possibility. You just list this number of possibilities right here, and you take that information. So again, this is called a table of values. Now with a table of values, what you can do is you can graph the information. So what we have over to the side right here is a graph grid that's blank, doesn't have anything on it. You can list anything on it, you can draw anything how you want on it. What I'm going to do is I'm going to grab my ruler right now and draw some lines on here. Specifically, I'm going to draw a vertical axis, and I'm going to draw a horizontal axis. Now when you draw these horizontal and vertical axes, you should always label the axes, what they represent. So in this case, the vertical axis represents our height, which was in millimeters, and our horizontal axis is time, which was represented in days. With that information, you now also list along the side and along the heights little dashes and what each dash represents. Now you don't have to list every single dash as to what they represent. You can actually skip a few and go to another one. So let's say I skip the first one and I write the second one. So the second one represents 2 days. The fourth one is 4 days, and so forth. You are not allowed to skip more spaces and change the numbers. You've got to make sure that the scale goes up on a reasonable scale. Now what I'm going to do is I'm going to choose the heights now. I'm going to start the corner at 0. You always start that corner at 0, 0. And again, I'm going to use the same kind of scale that I used for my horizontal axis for my vertical. You don't have to necessarily use the same scale, it could be a different scale. Okay, so now we take our table of values and we list each of these as points. So time 1, height 3, time 1 and height 3 is listed as this point. We go back, time 2, height 4. So time 2, height 4 is this point. The next point was time 3, height 5, time 4, and height 6. Now if this continues on, you can continue on with a pattern, if you notice what the pattern is. Now because time 0 could be representative, that could make sense at a height of 2 millimeters. And all other times and heights make sense here. So we're going to draw a line here. And put an arrow on the end so that it continues. This item that we've created right here is called a graph. This is a graph of this relation or relationship. Now taking a look at this graph and or taking a look at this table of values, you can also create an equation. Now creating equations are a little bit more challenging and take more time, most of the time. So we're going to create our equation here. Now because we have different variables represented here, specifically the time and the height, we have to use, we usually use one-letter variables to represent each one of these. So what I'm going to do is I'm going to start by defining my variables. And you start out by saying let, you choose a variable, and you say the word represent. So let t represent, in this case, the time. And if you happen to know the measure of units, you say it right here. So in days. I'm going to let h represent the height. And again, I know the units, so in millimeters. Now, the trick here is to, when you're coming up with an equation, you got to come up with an equation that fits with the number of time, or sorry, the variable t to be represented by some multiple or some addition or some subtraction. Some number of operations are being applied to the value t so that you can get the value of the height. Well, if you look right here in the table of values, you can notice the height is whatever the time is plus 2 in each of these cases. You might also notice it right here. Whatever the time is, you know the height is 2 more than that. So there's your equation. H equals time plus 2. And as I said, figuring out the equation can be a little bit more challenging. So if you're not able to figure out these equations right away, do not fret, do not worry. We will find other ways to find out these equations throughout the rest of our course that we're teaching you right here, or even in future math courses. Okay, so let's take a look at this situation. We're going to describe this relationship between the figure number and the total number of squares using a table of values, using a graph, and using an equation. Okay, so if you want, we can define our variables first. So let f represent maybe the figure number. So it asks us to find a representation between figure number and let say total number of squares, maybe n represent the total number of squares. So it already tells you which variables to actually use. Now you decide as to which one is your independent and which one's your dependent. Well, you might notice that the number of squares actually depends on which figure you have. So the number of squares has to go on the right, and the figure number has to go on the left. So we'll start out with the first three that we have here. 1, 2, and 3. Well, the first one has 3 squares. The next one has 5 squares. And the next one has 7 squares. Now you can start predicting what the pattern might be after that. So 4, I could get 9. 5, I could probably get 11, and so forth and so on. Okay, so now we're going to graph that. Since figure number that's negative doesn't make sense, and the total number of squares that's negative doesn't make sense, I'm just going to draw it in positive ranges of values of f and n. And again, remember to put the independent variable along the horizontal axis and the dependent variable along the vertical axis. So again, you can choose whatever scale you wish. This time I'm going to count by 3 to represent my figure numbers. I'm not going to list every single figure number, I'm going to list every second one. Now, because my number of squares actually increases by a larger amount here, at a faster rate, I'm going to use a smaller scale here for my vertical axis. I'm going to increase faster here. So this is going to be 2, 4, 6, 8. Now, time will help you guys decide which one's the better, what the better axes and scale to use. Okay, so the first time we have is 1 and 3. For figure number 2, we have 2 and 5. For figure number 3, we have 3 and 7 squares. And again, you might start to see a pattern developing here. Now, if you can't see everything on this scale, it doesn't make sense. Sorry, you don't have to draw everything. So you might notice the space up at the top from 14 to 18 is wasted. That's okay. Now, figure number 0 doesn't make sense. So I'm going to start at 1, and I'm going to increase. But also figure number 1.5 and 2.5 don't make sense, only positive whole numbers. So instead of using a solid line, I'm going to draw a dashed line here. We'll talk more about the solid and dashed lines later on. for the time being. If you do happen to use a solid line compared to a dashed line, it's going to be okay until we get to what it is later on. Okay, so now we're going to come up with an equation for this thing. As we've now got our table of values, a graph, now we come up with our equation. So again, it might take a little bit of practice to get better with this. I find using the table of values easier for myself. So, if you double your figure number, whatever that might be, and add 1, you get the total number of squares. Not sure if you realize that. So, double the value 1 plus 1 will give you 3. Double the value 2 plus 1 will give you 5. Double the value 3 plus 1 gives you 7. And so forth. So if that's the case, whatever f is, it'll give you the value of n. So your equation right here would be n equals 2 times f plus 1. And again, this can sometimes be challenging or problematic, but it just takes time for you to get better at it. So this is what I have to show you for lesson 3.1. Please reflect what you have learned and what things you remember in order to help you do better in the future. Thus concludes this lesson.